Welcome, Hornets, and thank you for joining me today. We're going to be working on assignment number, I believe it's 10. This is found on page 405, numbers 1 through 25, odds only, then 35 through 37, 45, 53, and 61. Please be aware, in part 1, I'm only working on page 405, numbers 1 through 25, odds only, and I will only be doing the first 17. The remaining problems I'm going to leave for you to try and do on your own. So we're going to go ahead and we're going to start with number 1. Number 1 is asking us to find the general solution. We are being given dy dx is equal to x divided by y. We start by separating our variables, just as we always do, and then we put our integration down. We now integrate, giving us 1/2 y squared equals 1/2 x squared plus c. Now, if you want to use the subscript c sub 1, you may. I am not. There is absolutely no reason. It's just a constant, and therefore, as I multiply by 2, I just have to call it constant 2. After all, it's still a constant, but it's a different constant. So leave out the subscripts. Now be aware, for the book, they expect you to go y squared minus x squared equals c. However, the real solution that we are trying to find is y equals, and that should be plus or minus the square root of c minus x squared. That's what I'm expecting you to do, and that is what the AP is expecting you to do, and that is what a college professor is expecting you to do. They are not going to ask for the y squared minus x squared equals c. So just be aware. The textbook has its own way of doing things, and I don't necessarily agree. Number 3. Number 3 is asking us to take x squared plus 5y dy dx equaling 0. Now what you want to do is you want to move this piece over so that you have 5y dy dx is equal to negative x squared. Now, I like to divide by the 5 so that I have my dy all by itself. It gives me a negative 1/5 x squared dx, and that's what I prefer to work with. Now that I have it set up, I'm going to have my 1/2 y squared equals negative 1/5 multiplied by 1/3 x to the third plus c. Multiplying by 2, I end up with y squared equals negative 2/15 x cubed plus c. Now, the book is going to expect you to have 15y squared plus 2x cubed equals c, but that's not what we do. We find what y equals, and therefore y will equal our square root plus or minus c minus 2/15 x cubed. That's the solution. That is a y equals. That's what we want. Please don't make any mistakes as to what I'm expecting versus what the silly textbook is expecting. Going to number 5. They give you different letters. drds is equal to 0.75 r. Now, I don't like the decimals. I can leave it there, but I'm not. I'm going to go ahead and make it 3/4 so that I end up with my dr 1 over r equals 3/4 ds. I'm now going to integrate 1 over r dr is equal to 3/4 the integration of ds. This allows me to integrate quite cleanly, getting the natural log of the absolute value of r equals 3/4 s plus c. Now I can exponentiate. This is now giving me r equals, I have e to the c times e to the 3/4 s. And since e to the c is a constant, we call it c. Now, if you wish to call it 0.75 s, you may, but that is our answer. R equals ce to the 3/4 s, or r equals ce to the 0.75 s. Number 7 now gives us 2 plus x, y prime equaling 3y. Now I recommend you change this to dy dx, and I'm going to make this 3y divided by 2 plus x, and now I can separate my variables. Once again, I like my constant to not follow y. However, the book generally will. I don't know why they do that. They seem to think it's easier. I disagree. Now, I'm looking at integrating y dy and 3 times the integration of 1 over x plus 2 dx. This is giving me 1 half y squared, and I then have 3 natural log of x plus 2, don't forget your absolute value, plus c. This is going to, let me just make sure I got that correct. It is 1 over y. Hang on a moment. I do have an error. I was thinking about that because I have divided by y, and it is a 1 over y, and that's giving me the natural log of the absolute value of y. I now am exponentiating both sides. This gives me y, and I have a constant. And let's just see this as a e to the natural log of x plus 2 absolute value to the 3rd power. And then I have times e to the c. These are canceling, and it's going to give me y equals c times x plus 2, the quantity cubed. And there's my answer. Let's go to number 9. Number 9 gives you y prime is equal to 4 sine x. Therefore, I have dy dx, y equals 4 sine x. Separating my variables, I get 4 sine x dx. I'm now going to integrate y dy equals 4 integration of sine x dx. And as I integrate, I get 1 half y squared equals negative 4 cosine x plus c. Multiplying by 2 gives me y squared equals negative 8 cosine x plus c. Once again, it's still a constant. And the book is going to have you have something of this nature here. But we always want to find what y is in terms of the x's. So we're going to have plus or minus the square root of c minus 8 cosine x. And this is the answer that I would expect you to give me. Number 11 is next. Number 11 is giving us the square root of 1 minus 4x squared times y prime equal to x. I'm going to move this down to the bottom so that I have my dy dx is equal to x over the square root of 1 minus 4x squared dx. This is going to allow me to do, so I'm moving the dx. Let's take it in 3 steps, Mr. Lamb. Trying to rush through it, and I shouldn't. That's something that you should always watch out for. Trying to rush through a problem is just setting yourself up to make a mistake. And you've seen me make many in the past years, so hopefully I'm giving you a good example of what to avoid. I'm now going to integrate dy. I'm going to integrate x over the square root of 1 minus 4x squared dx. I'm going to use a u substitution, 1 minus 4x squared. The du is therefore giving me negative 8x dx. I only have an x dx, so I have a negative 1/8 du is equal to that x dx, and I'm now replacing. I'm going to end up with a y equals the integration of u to the minus 1/2 power. I have a negative 1/8 out in front and my du. Now I can integrate, and I get y equals a negative 1/8 multiplied by 2/3, and, multiplied by 2 over 1 times the square root of u plus c. This is giving me y equals negative 1/4 the square root of 1 minus 4x squared, the quantity, plus c, and that's my answer. Alrighty, this is going to now bring us to number 13. This is the last of our problems in part 1 where we're finding general solutions. And number 13 gives us y natural log of x minus x y prime equaling 0. I want to move this piece over, or I want to move this piece over. Now you'll notice it doesn't matter which. If I get a negative, I'm going to make it a double negative by multiplying by negative on both sides. Either way, you should end up with x dy dx is equal to y natural log of x. And I like to put my absolute values around it. Granted, they're obviously saying that the domain is going to be all x values greater than or equal to 0 based upon the information they've given me right here. But I like the absolute value. Keeps me honest. So I have 1 over y dy, and I'm looking at the natural log of x, and let's see, and I'm going to have an x in the denominator and a dx. So this is what we're working with. I'm going to integrate 1 over y dy. I'm going to integrate the natural log of x over x. Once again, I prefer that absolute value in there, dx. And I'm going to have to use a u substitution. If u equals the natural log of the absolute value of x, then du equals 1 over x dx. You'll notice that I'm looking at the u. So I get I get the natural log of y equaling, in this case, we have the integration of u du. And if that's the case, I'm going to have a 1/2 u squared plus c equaling the natural log of the absolute value of y. I'm now going to put it back in and exponentiate. So I have the natural log of the absolute value of y equals 1/2. And we are looking at the natural log of the absolute value of x, the quantity squared, and we have our plus c. Alrighty. Let's just make sure that I haven't forgotten anything. So I have my u du. Okay, this is now time for exponentiation. I'm getting y equal to, and I now have the square root, or 1/2. Let's do e to the 1/2 natural log absolute value of x, the quantity squared, and I have it multiplied by e to the c, and therefore my final answer will end up being y equals ce to the 1/2 of the natural log of x, the quantity squared. And there's my answer. This will bring us to number 15. Now, number 15 is asking us to find a particular solution. They give us the equation of y prime minus 2e to the x equaling 0. And we want to make sure that we get everything to one side, leaving our y prime alone. So start by solving for y prime. You're going to end up with 2e to the x divided by y. Now rewrite it so that it is dy dx equal to 2e to the x divided by y, and separate your variables. Y dy equals 2e to the x dx, and that's what we're going to integrate. Everything else at this point should follow quite cleanly. 1/2 y squared. I'm getting a little bit tired. It is past 7, heading towards 7:30 in the evening. And I'm a little tired. So we have 2e to the x plus c. I'm now going to multiply by 2 so that y squared is equal to 4e to the x plus c. I'm now going to take my square root so that let's plug in our point. They did give us an initial condition, and that was 0, 3. So I have 9 equals 4e to the 0 power plus c, and that means that 9/4 is equal to c. Let's make sure I have that written correctly. I have a problem. I'm subtracting. So I have 9 equaling 4 plus c equals 5 equal to c. So that I can now write it as y squared equals 4e to the x plus 5. Now when I take the square root, I now get y equal to plus or minus the square root of 4e to the x plus 5. Now because they gave us this positive y value, we know that our answer is the positive square root, the upper portion of that relation. And this is the particular solution that we're looking for. It is very different from what the book expects. The book expects you to have this answer, and I disagree because although it is a relation and it is going this way, it is not a function. They are asking for a particular function or solution. So just be aware there are issues and problems with this. Let's go ahead and take a look. The last problem that's being done today, this is number 17. Number 17 is giving you y x plus 1 plus y prime equals 0. You're going to want to move everything over so that you end up with negative y x plus 1 equaling dy dx, so that you end up getting negative 1 over y dy is equal to x plus 1 dx. With this, I can now work with negative natural log of the absolute value of y is equal to 1/2 x squared plus x plus c. We're going to have to multiply through by the negative so that we have the natural log of y equals negative 1/2 x squared minus x. We keep it as a plus c. Exponentiate, and you're now looking at y equal to a constant e to the negative 1/2 x squared minus x power. Now keep in mind that we could call this with the negative here, we could bring this down and have it divided by e to the x, but I see no reason to do that. All right, this will now allow me to plug in my point. The point that they're giving us is negative 2, 1. So I have 1 equal to CE to the negative 4 divided by 2, and I have plus 2. This is giving me a 0, so that C equals 1, and I'm now going to put that in as y equals e to the negative 1/2 x squared minus x. And that's the solution that I'm looking for. That is part 1 of classwork number 10, or assignment number 10, found on page 405, numbers 1 through 35, odds only from part 1 of this assignment. Tomorrow I will be putting up part 2, where I will be going over numbers 35 through 37, 45, 53, and 61. Thank you very much, Hornets, and I hope this has helped you. Please be well and be safe, and take care. Bye now.